In this lesson, we are going to see some examples of how to find area when given a pair of similar figures. So when given a pair of similar figures, the first thing you want to do is find the side length scale factor. And we're going to abbreviate that SLSF. Once you have the side length scale factor, then you can find the area scale factor. And we'll abbreviate that ASF. So let's start with side length scale factor. So to find side length scale factor, you take one side on one of the figures and you write it as a ratio with the side that corresponds to it. So 10 corresponds to the 15. And then we're going to simplify. So in this case, you can divide both of these by 5, so you end up with 3 over 2. So the side length scale factor is 3 over 2. So now, to find the area scale factor, the relationship between side length scale factor and area scale factor is that the side length scale factor squared equals the area scale factor. So what we're going to do is we're going to take this side length scale factor here and we're going to square it. So 3 squared times 3 squared. Excuse me, I totally misspoke. 3 over 2 times 3 over 2 equals 9 over 4. So the area scale factor is 9 over 4. So now that we have the area scale factor, now we know how the areas compare to each other. And they compare to each other by a ratio of 9 to 4. So what we do is we write a proportion now. And we are given one area, and the area we're given is the area of the small figure. So that area needs to go across from the area of the small number. So when you look at 9 and 4, the smaller number is 4. So the 24 is going to go across from the 4. And then x will go across from the 9. So the next thing we're going to do now is solve our proportion. So we're going to do 9 times 24. And that equals 216. And then when we do the other cross product, we get 4x. So now we're going to solve for x by dividing both sides by 4. So 216 divided by 4 equals 54. So x equals 54, and this is going to be meters squared. So what we just figured out is if these two figures are similar, then this area would have to be 54 meters squared. Example. All right, so again, we are going to start by finding our side length scale factor. And then once we have that, we're going to find our area scale factor. Okay, so side length scale factor, the way that you find that is you take one of the side lengths that you're given, 9, and you write that as a ratio with the corresponding side length, in this case 5. Now 9 over 5 does not simplify, so I'm going to leave that 9 over 5. So now to find the area scale factor, again, side length scale factor squared equals area scale factor. So if I do 9 over 5 times 9 over 5, I will get the area scale factor, which then would be 81 over 25. So that is the area scale factor. So the next thing we're going to do is we're going to take that ratio of, or that area scale factor, 81 over 25, and we're going to write a proportion because now we know how the areas are supposed to compare. So when I go up to the top here and I see that the area of this figure is 20, I now need to decide where the 20 is going to go, if it's going to go on the top or the bottom of the proportion. So since 20 is on the big figure here, it needs to go across from the big number. So it's going to go across from 81 because it's bigger than 25. And then x will go on the bottom. So then the next thing we're going to do is solve our proportion. So we're going to do the cross product. So we get 81x equals, and we're going to do 20 times 25, which gives us 500. And then we're going to solve for x by dividing both sides by 81. So 500 divided by 81 gives us approximately 6.2, and this is going to be feet squared. So this is 6.2 feet squared. So if these two triangles were similar triangles, the area of the small one would be 6.2 feet squared. All right, let's do another example. So again, we start this process by finding the, hold on one second. I'm going to go ahead and erase that. That was incorrect what I wrote. Okay. All right, we're going to start by finding the side length scale factor. And then after we find that, then we're going to find the area scale factor. Okay, so to find the side length scale factor, you take the ratio of the sides. So 6, and then 6 corresponds to 15. And in this case, we can divide them both by 3, so we end up with 2/5 for our side length scale factor. So now to find the area scale factor, I need to take that number and multiply it by itself, because the area scale factor is the side length scale factor squared. So the area scale factor would be 4/25. All right, so the next thing we're going to do is take that ratio, 4/25, and we're going to write it as a proportion. So I'm going to take the area that I'm given, which is 24, and since 24 is on the small figure, it needs to go across from the small number. So it's going to go across from the 4. And then x is going to go here. So then we're going to solve this by doing the cross product. So we get 4x equals, and then we're going to do 25 times 24, which is 600. And then we can solve by dividing both sides by 4. So x equals 150, and this would be centimeters squared. So if these two figures were similar, the area would be 150 centimeters squared. Okay, so again, we're going to start by finding the side length scale factor, and then after we have that, we're going to find the area scale factor. The side length scale factor in this case is going to be 15/7, because that's the ratio of the corresponding sides, and it does not simplify, so that's the side length scale factor. The area scale factor is the side length scale factor squared. So I'm going to do 15 times 15 to get 225 on the top, and 7 times 7 to get 49 on the bottom. So that is the area scale factor. Okay, so now that we have the ratio, 225/49, I'm going to take that and write that down. And I'm going to set up a proportion. So they tell me that the area of the big triangle is 25. So that means that 25 needs to go across from the big number. So it's going to go across from 225. And then x is going to go on the bottom. Okay, so now we're going to solve by doing the cross product. So we get 225x equals, and we're going to do 49 times 25, which is 1,225. And then we're going to solve by dividing both sides by 225. So those cancel, and we get x equals 5.4 repeating. And this would be centimeters squared. So if these were similar figures, the area of the small figure would be 5.4 centimeters squared. So those are some examples of how to find the area when given two similar figures.